All right, good day, viewers. It's very good to be back again. Good to have you back again. Today we'll be taking this topic, as you can see on your screen, derivative of logarithmic functions, and we'll be considering two formulas in treating this topic. We also consider 4 different questions. Let's get right into it. All right, like I said earlier, we'll be taking derivative of logarithmic functions. As you can see on your screen, you have the first one. The first formula is here that says if y equals the log of u base a, and of course your u is a function of x, then we are going to have these as a formula. Then your derivative of that function, that is the derivative of y, will be u prime over u log a base e. Okay, you can as well write it in another form, and if you recall that you can express log a base e, that's the natural log of a, in this form, ln a, or some call it ln a, or you can also call it ln a. So if you recall that this equals ln a, I will simply replace what I have the denominator with ln a. Then we're going to have that formula expressed in this manner. Okay, I'm going to have it expressed in this manner. We have dy dx will be equal to u prime over u ln a, because we have replaced the part of the denominator, okay, which is log a base e, writing it, that's the natural log of a, so we are writing it as in a. So that's why we have it written this way. So we'll be making use of that as our formula. All right, so either you have it in the first format, like in this case, or you have it this way. So what I prefer this last one, considering that. Let's consider the second formula that we'll be using. All right, so now if you look at it very well, the first one that we considered is a bit different from this. The first one was expressed in this way. You have your y was written as log of u, function of x, base a. But this time around we are having it in a different way. You are having your y to be the log of natural log of u. Okay, you are having it expressed in the natural log of u, but the first one that we have here is not. Okay, so because of this, the outcome when we take the derivative of y, in this case is going to be different. So then we are going to have our formula this time around will be u prime over u log e base e, u prime over u log e base e. And if you also remember, all right, if you also remember from the law of logarithm that we have done before now, you have log e base e to be equal to 1. So because of that, we are going to replace log e base e that we have here. We are going to replace it with 1. So, and that will lead us to this expression, okay? Because once we have expressed this dy dx, which is equal to u prime over u log e base e, and I said earlier on that log e base e is 1. Okay, now in that case I will write this as u prime over u multiplied by 1. So you will end up having u prime over u. Okay, so just keep this in mind. These are the two key things that I'm going to make use of as we go on. Okay, so let's consider the first question that we have here. It says you should find the derivative of y equal to ln x squared. You find the derivative of y equal to ln x squared. So here we have the formulas placed here. So we are going to check, before we proceed, we are going to check which one of the two is suitable to be used for this question. So we have y equals ln x, not y, it's ln x, ln x raised to the power 2. Okay, now it appears as if we don't have anything that is relating to this question in that formula, but I will rewrite this in another form so that you can see clearly. If you have ln x squared, you can rewrite it as the log x squared base e. Don't forget your ln is representing the natural log. What I mean by that is, if you have log of whatever to base e, log of anything to base e, you can simply write it as ln whatever. So that is what we are trying to say. So I have written ln x raised to the power 2 in another form. So in this case, I believe we should be able to relate with what we have with our formula. We should be able to relate now. Okay, so if you look at it very well, if you check the first formula, this doesn't seem to be suitable for the question that we have. If you look at it very well, if you check, we have log x squared base e. So the only thing you have to target is the one that has base e, right? So if you look at it very well, this one has base e. So this one is the suitable one for what we are about to do. So in that case, we will identify what our u is first. I'm referring to this denominator here. Okay, then we now take u prime, which is the derivative of u. All right, so now let us identify what our u is. So if you look at it very well, now if y equals to log u base e, then dy dx will be equal to u prime over u. So if I compare this u, which is a function of x, with the one that we have here, I can easily say that my u represents x in this place. X squared is represented by x squared. So in that case, I know in my formula I will be in need of u prime, which is the derivative of u. So I will differentiate this. Okay, this u prime is the same thing as you saying du dx. See the same thing. So you have 2x when you differentiate u prime. So we have gotten all that we need. So therefore we can conclude by saying dy dx, all right, dy dx equals, what's our u? What are u prime? That's 2x, then we say divided by u, and our u is x squared. But I want you to also remember that we can still express this as I can still write this as 2x over x multiplied by x. Alright, because x multiplied by x will give us x squared. So in that case, I'll be privileged to take out one of these x's that I have here. So I have 2 over x left. So this is my final answer for the first question. That's my final answer, right? So I think we can consider another question now. Okay, so let's take another question. We have second question says you find the derivative of y log 4x minus 1 is e. You have to find the derivative of y equal to log 4x minus 1 is e. Okay, so we have y equals log 4x minus 1 is e. So comparing again, you go to our formula again. That formula, the one that is suitable for it again, is the one that has the base to be e. So if you look at it very well, the first one has a, base a. That one we cannot use that one, but we are going to use the second one. This is the suitable one for this question. So and that formula says that our dy dx is going to be u prime over u. So I will take my u, right, to be 4x minus 1. 4x minus 1. This is my u. Okay, this is my u. So I will say my u is a net u. Okay, it is 4x minus 1. Therefore, now if you come back to that formula, we need u prime. U prime is the same thing as du dx. So I will take that now. U prime equals, if you differentiate 4x, we have 4. And if you differentiate negative 1, you are going to have 0. So our answer here for u prime is 4. So in that case, you can easily say that dy dx in this case will be, what does the formula say? U prime over u. So I'll put u prime up here, which is 4, okay, over u. What's u? U is 4x minus 1. 4x minus 1. And with that, we have concluded example 2. So that's the end of example 2. So proceed to the third one. We proceed to the third one. Okay. The third question says we should differentiate y equals log 3x squared plus 4x base 10. Base 10. Okay, I would like to say that our a, for instance, okay, let me just take this way. Y equals log 3x squared plus 4x, okay, all in bracket, base 10. Now in this case, I would like to say that our a actually represents any available constants. Constant is a constant. Likewise, we have u to be the same, but the a that we have here represents any other number. We have, for instance, this 10 that we have here is standing for a. Okay, now we don't have it as e in this case. Okay, we don't have it as e. In this case now, this is not a variable, not a variable x. Okay, it's just a is a constant, but your e is the exponential is a special kind of constant. So in this case now, we are dealing with 10. Our base here is 10, which is standing in position of a in this case. So we'll make use of this first one, which is the general formula. Okay, we'll make use of the first one in this case. All right, so we have y. If you make use of the first one, we identify what our u is and what our u prime is as well. So in this case, if you look at it very well, we have our u to be 3x squared plus 4x. So in that case, we will take the derivative of u with respect to x, and we are going to have 6x plus 4. 6x because your 2 will come down this way, right, to come and meet 3. So you have 2 multiplied by 3, and at the same time you are going to remove 1 from 2. So we have done this before. I believe you know what this is all about. So we are going to take our dy dx now, and that will be according to the formula. We are going to use the first one in this case. So we have u prime. What's u prime? That's 6x plus 4 over u. What's u? We have 3x squared plus 4x into bracket. Now there's something special here. We have in a, and once earlier I said it earlier that a is the same thing as 10, and this 10 is the one standing in position of a. So instead of me writing in a, I'll write in 10, because our a is actually 10. So I'm going to put a 10 in place of a. Okay, so that's the end of the third question. We take the fourth one. Now this one says we should find the derivative, or we take the differentiate y equals to square root of 7 plus x. Differentiate y equals to 7 square root of 7 plus x. So now let's see which one of the formulas that we have is actually suitable in handling this question. Okay, so we have y equals the square root of 7 plus x. Now I want to remind you again of what we did in one of those questions. I will rewrite the ln as natural log, the log to this e of what I have here, square root of 7 plus x. Okay, and don't forget that you can also express log root 7 plus x as 7 plus x. You open a bracket, you close the bracket, all raised to power half. All raised to power half. Alright? All raised to power half. So if you recall from law of logarithm, that you can rewrite this as y equals, you can bring this half to the back of the log, bring it to the back this way, then you have 1 over 2 log 7 plus x base e. Now what I did is this. If you recall that under logarithm, if you have log x raised to power n, okay, log 2, let's just say this is base 10. You can have this as, you can express this as your m coming to the back, okay, and you have n log x base 10. So that's just the principle that I used here. I brought this half to the back of the log. So we are going to deal with this without the half. The half will be taken as a constant. All right. So in that case, we have to go back to the formula actually. So if you go back to the formula, we'll be taking the half as a constant. Then we will consider that log alone when we are considering or checking our formula. Let's see the 2 and see which one is suitable. Now we have this one is having log to base e. So definitely for sure we are going to use the second formula, which is this. All right. So therefore, as long as our y equals to log u base e, and we concluded that dy dx is going to be u prime over u. So the question is, what's our u and what's our u prime? So if you look at it again, if you look at it here, you find out that our u is u is actually 7 plus x. It's the one standing in the position of u. If you look at the formula, right, it's the one standing in the position of u. Okay, so you call your u as 7 plus x. So in that case, you take u prime. Now if you differentiate 7 is a constant, that will be 0. And if you differentiate x, your answer is going to be 1. Okay, so we now take our dy dx, in this case will be what's the formula? U prime. What's u prime? That's 1 over what's our u? 7 plus x. But we are not going to throw away the constant that we have, this half. Okay, so we multiply the whole thing by half. So we are going to have that is, we are going to have 1 over 2 multiplied by 1 over 7 plus x. So in that case, you can express it as 1 over 2 bracket 7 plus x. So this is our final answer for the fourth question. So I think we should stop here for today. I'm going to take, I left for you an exercise for you to practice with. So you can consider the exercise, and if you have any question, you can let me know in the comment section. Thank you. I'll see you next time.